Imagine a world where the sun, giver of life, suddenly vanishes, or the moon, guardian of the night, bleeds red. For millennia, these celestial disruptions, eclipses, were terrifying omens, portents of doom, or divine wrath. But hidden beneath the terror was a profound human curiosity, a relentless desire to understand the heavens. Without telescopes, without modern computing, ancient civilizations achieved something truly astounding. They predicted these cosmic events with breathtaking accuracy. How did they achieve such a feat? This is the story of intellect, perseverance, and humanity's enduring quest to decode the universe. To predict an eclipse, one must first grasp its mechanics. An eclipse is a shadow play, a precise alignment of the sun, earth, and moon. A solar eclipse occurs when the moon passes between the sun and earth, casting its shadow upon our planet. A lunar eclipse happens when the earth passes between the sun and moon, bathing the moon in Earth's shadow. These events are not random. They are governed by celestial mechanics, a cosmic clockwork that ancient observers meticulously unraveled through centuries of patient watching. Initially, eclipses inspired profound dread. Ancient texts from virtually every culture speak of eclipses as ill omens. Kings fell, battles were lost, and famine followed, all attributed to the temporary disappearance of light. Yet, this fear eventually spurred systematic observation. Priests and astronomers, recognizing patterns in the chaos, began to record these events, marking the dates, times, and appearances. This meticulous record-keeping was the first, crucial step toward demystifying the heavens. Among the earliest and most sophisticated celestial observers were the Babylonians, who lived in Mesopotamia over 3,000 years ago. Their ziggurats doubled as observatories, where priests, known as Chaldeans, tracked planetary motions, lunar cycles, and eclipses. Using cuneiform tablets, they compiled vast libraries of astronomical data, identifying recurring cycles. These weren't mere superstitions. Their records were mathematical tables, charting the paths of celestial bodies with incredible precision, forming the bedrock of predictive astronomy. The greatest Babylonian discovery for eclipse prediction was the Saros cycle. This remarkable pattern dictates that solar and lunar eclipses recur in almost the same sequence every 18 years, 11 days, and 8 hours. The Babylonians deduced this without understanding the underlying physics. They simply saw the repetition in their extensive records. This 223 synodic month period allowed them to anticipate when and where similar eclipses would appear, a truly monumental intellectual leap that transformed astrology into astronomy. Across continents, other civilizations independently pursued similar astronomical quests. In ancient China, imperial astronomers meticulously recorded eclipses, believing them to be warnings for the emperor. Failure to predict an eclipse was punishable by death. Meanwhile, the Mayan civilization in Mesoamerica developed an extraordinarily complex calendar system and sophisticated mathematical models. Their Dresden Codex contains intricate tables for predicting both solar and lunar eclipses, demonstrating an advanced understanding of the lunar cycle's irregularities. The ancient Greeks inherited much from Babylonian knowledge, refining it with their geometric and philosophical approaches. Thinkers like Thales are credited with predicting eclipses, though details are scarce. Later, Hipparchus, using mathematical principles, calculated the precise duration of the lunar cycle and further refined eclipse prediction. The Antikythera mechanism, a complex ancient Greek analog computer designed around 150 to 100 BCE, could predict astronomical positions in eclipses, showcasing a stunning level of mechanical and astronomical sophistication. How did they achieve such precision without telescopes? The answer lies in patient, naked eye observation over centuries, coupled with ingenious instruments. Gnomons, simple sundials, stone circles like Stonehenge, and dedicated observatories allowed them to track the sun's path, the moon's phases, and the movements of stars. By marking solstices, equinoxes, and precise positions of celestial bodies, they built reference frames, allowing them to measure angular distances and map the sky with remarkable accuracy, preparing for the rare alignments. While the Saros cycle provided a reliable 18-year, 11-day pattern, the 8 hours posed a unique challenge. This fractional day meant that an eclipse in a new Saros cycle would appear roughly 1/3 of the way around the Earth from its predecessor. This geographical shift required not just timing, but also an understanding of the Earth's rotation and the Moon's orbital tilt, known as the nodes. Ancient astronomers deduced these intricacies through diligent tracking and complex arithmetical progression over many Saros cycles. The ability to predict eclipses was not just a scientific triumph, it was a profound assertion of human intellect over the perceived chaos of the cosmos. It elevated the status of the astronomers, granted immense power to rulers who could command or foresee these events, and facilitated the creation of more accurate calendars crucial for agriculture and religious festivals. These ancient predictions represent humanity's first great victory in understanding the vast, impersonal mechanisms of the universe, laying the groundwork for all future scientific inquiry. The methods developed by these ancient cosmic architects, systematic observation, meticulous record-keeping, and the identification of recurring cycles, form the very foundation of modern science. Their profound insights, achieved without the aid of sophisticated instruments, underscore the incredible power of human curiosity and deductive reasoning. They transformed celestial terror into predictable spectacle, paving the way for a deeper understanding of our place in the universe, a legacy that continues to inspire astronomers and dreamers alike. From the fear-filled silence of a darkening sky to the triumphant certainty of prediction, the journey of ancient civilizations to understand eclipses is a testament to human ingenuity. They didn't just observe the heavens, they decoded its language, revealing patterns in the cosmic dance that continue to astound us. Their legacy is a profound reminder that even in the face of the unknown, humanity's drive to question, to record, and to understand has always been our most powerful tool, connecting us across millennia to the timeless mysteries above.